Hi. In this video, let us solve few more problems by using LH rule, and we are going to see the problems in the form of 0 power 0 or infinity power 0 or 1 power infinity. Let us solve these problems one by one. Let us take the first question. In all these type of problems, it is limit extends to some some function. If you see f of x power g of x is there. Everything is there in the power. All three types if you notice. So our first work is to bring down the power to the numerator. So now we all know that log m power n is n log m. It will come down from the power. Correct? So what we are going to do is apply log on both sides. Whenever power is there, you take log on both sides. Now what we'll do? Log k is equal to log of 1 minus x square power 1 by log of 1 minus x. Now this power comes down. Log k is equal to 1 by log of 1 minus x into numerator what we have? Log of 1 minus x square. Okay, so now this is of the form, if I substitute x is 1, log of 1 minus 1, log 0, again infinity. The infinity by infinity form is there. Let me write the limit. Limit x tends to 1. I must write the limit. So it's an indeterminate form. Let us apply LH rule. When you apply LH rule, what we will do? We will differentiate numerator separately and denominator separately. Your limit will be as it is. Log of something, if you differentiate 1 by that value. So log x means 1 by x. Here instead of x what we have? 1 minus x square. So we have written 1 by 1 minus x square. And differentiation of whatever the function is there. So very simple. Log of something is 1 by that something into differentiation of that something. That's it. Divided by same rule. What we are going to do? Log of 1 minus x is in the denominator. What we will write? 1 by 1 minus x into differentiation of 1 minus x. If we simplify this, let me write limit x tends to 1. 1 by 1 minus x square. So numerator 1 minus x square differentiation is minus 2x divided by 1 minus x square divided by 1 minus x differentiation is 1 differentiation is 0 minus x differentiation is minus 1 by 1 minus x. This minus and this minus will get cancelled and the terms, if it flips to the numerator, 1 by 1 minus x will become 1 minus x by 1. And in the denominator, we have 1 minus x square. Now, what we are going to do, if we try to apply the limit again, x if you put 1, numerator also will become 0, denominator also will become 0. And we can use a very basic identity we know for a longer time. That is log k is equal to limit x tends to 1. Let the numerator be as it is. Denominator 1 minus x square, I can write it as 1 minus x into 1 plus x. This and this cancel because unless and until we have that 1 minus x term, again and again it will become 0. So we have simplified it. Now if we substitute x as 1, 2 into 1 by 1 plus 1, that is nothing but 2 by 2, which is 1. Hence, limit x tends to 1. Your final answer is for log k is equal to 1. But the problem is not over here because we want k, correct? If you see, we have the question named as k. We have taken log on both sides. But we want the limit for k. So what we are going to do? We are going to do the reverse process of this log. So what is the reverse process of log? We are going to take to the power e. So we can write it as log of e power log k is equal to e power 1. E power log of something means we'll get the same function, which implies k is equal to e. We are raising power e on both sides to get the solution. So always remember, whenever there is a power, we are taking log on both sides, and then we are finally taking e power, raising to the power e on both sides to get the answer. So let's see the next problem. Here is the second problem, and as you see, the power is there, so we have to take log on both sides. So I have assumed let this is k, so it's easy for us. Log k is equal to limit x tends to 0, 1 log of 1 by x power 2 sin x. As I told in the previous problem, log of m power n is n log m. And you'll be wondering that when we take log k, automatically it is natural log, which is nothing but ln in your calculator. So if you want, you can mention the base, or you can write simply log k, because it's understood that we are using the natural log. And now log k to the base e is nothing but the power will come down 2 sin x into log of 1 by x. Your limit is x tends to 0. Now if I simplify this further down, we get log 1 minus log x on the other side. Because it is, we are using the formula, let me write here, log of a by b is equal to log a minus log b. Numerator minus denominator. So numerator is 1, denominator is x. But this answer is 0. So we have 0 minus log x into limit x tends to 0 to sin x. If I multiply this inside, minus limit x tends to 0 to sin x into log x. So you can take this minus 2 also to the beginning, because we are going to apply the limit minus 2 into limit x tends to 0 sin x log x. So again, we want a numerator as well as denominator to apply LH rule. So what we can do, the sin x, if I take it as to the denominator, minus 2 into limit x tends to 0, this I can write it as log x divided by 1 by sin x. Correct? So 1 by sin x, if it comes to the numerator, it flips and we'll get sin x. And this 1 by sin x is nothing but cosecant x. Now we got one numerator and denominator. And now if you see infinity by infinity form, so what we can do? We can apply LH rule. So we are taking the power, and keep this in mind, on the left hand side what we have, log k. That, and let me write, we apply LH rule. Write down the LH rule statement for the exam. So limit x tends to 0, log x differentiation is 1 by x, and cosecant x differentiation is minus cosecant x of x. And if we try to apply the limit directly, what is cosecant 0? That is sine 1 by sine 0, correct? Sine 0 is 0, infinite form it takes. But always remember, limit x tends to 0. And this in product, in the previous video, I have mentioned that we can use the property limit x tends to 0 sin x by x. Now I am bringing it to the numerator. Cosecant x, again I am taking it to the numerator. Sin x by x. And then we can split it, limit x tends to 0. The second term, that is log x. Okay. So Let me write this. Yes, we will write this 1 by cot x as tan x. Okay, so this cosecant x goes to the numerator, minus 2 into, what is this term? Limit x tends to 0, sin x by x is 1. We can use this direct result. And what is tan 0? 0. So everything will become 0 and hence we will get log k 0. But actually what do we want? K. So e power log k is equal to e power 0. What is e power 0? E power 0 is 1. And e power log of something is that something, and we will write this k as 1. So this is the solution for the second problem. Let's go for the third one. This is our question 3. We have written the question and just named it as k. And of course there is a power here, so we are taking log on both sides. Same concept, log m power n is n log m. So that the power that we have, that is tan pi x by 2a, comes down and we got this function. So log k is equal to this. And we want one numerator and one denominator for LH rule. So what we will do, limit x tends to a, log of 2 minus x by a divided by 1 by tan of pi x by 2a. So 1 by tan means it will come to the numerator, which is same as this step. Okay, what is 1 by tan? Which is nothing but cot. In the previous problem, 1 by sine we converted that to cosecant. So this is nothing but limit x tends to a, log of 2 minus x by a by cot of pi x by 2a. You can pause this and try to solve it on your own. And before solving it, we are just checking. If we substitute x as a by a will become 1, log of 2 minus 1, which is nothing but log 1, and this log 1 is 0. So numerator is 0 and denominator substitute a and a will get cancelled, cot pi by 2 again, which is 0 because tan pi by 2 is infinity, so cot pi by 2 is 0. If it is 0 by 0 form, we'll apply LH rule. Now we'll differentiate the numerator separately. Log of something means 1 by that something into differentiation of that. So d by dx of 2 minus x by a. Similarly, cot x differentiation is minus cosecant square of that something, not only simple x is there, into d by dx of that value, pi x by 2a. Now we have to just simplify this. We have written the same thing here. And d by dx of 2 minus x by a is minus 1 by a. X differentiation is 1. And denominator pi x by 2a, pi by 2a is a constant, x differentiation is 1. And this minus will become plus. And we have to just substitute the limit and we have to find out what we are getting. That is log k is equal to limit x tends to a. Let us substitute if x is a. 2 minus a by a, that is 2 minus 1 into 1 by a divided by cosecant square pi into a by 2a into pi by 2a. This and this will get cancelled and we will get cosecant square pi by 2. So cosecant square pi by 2 is inverse of sine. What is sine 90? Sine 90 is 1. So the denominator will become, this term will become 1. And 2 minus 1 is 1. So the numerator we get only 1 by a. Let me simplify. So this pi by 2a, if it flips to the numerator, 2a by pi, a and a will get cancelled, 2 by pi. Again raising to the power e power log of k is equal to e power 2 by pi. Therefore e power log of something is that. So k is e power 2 by pi. So we have seen 3 different problems, and what is a common thing? We have a power. So to get rid of that power, we will take log on both sides and we'll continue. At the end, we'll reverse the process to get the value of k. Thank you.